Sir, the Amit Kumar Chaudhary, sir. He is the head technology and training in Pragyatmika Technologies. So he will be sharing his knowledge related IoT and industrial automations. So I'd like to invite sir to share his knowledge and on the IoT and industrial automation systems to our students.
Thank you, sir. I hope I'm good audible to you.
Thank you, sir.
Shall I start, sir?
Yeah, you are audible, sir. Yeah, you can start, sir.
Okay. So I'm starting. So first of all, I thank you all for inviting me into this wonderful webinar on IoT and industrial automation, which is your initiative to let know everyone about the latest into the technologies, the implementations of it, and how we can leverage the latest of the technology for the benefit of the mankind. And in this series, the industrial automation is a very latest of the things that is happening for the not only for the manufacturing practices, but also for the enhancements of our lifestyles. So industrial automation, I can say that it is not only relevant only to the technologies, but services and your lifestyle and everything that is getting hindered by us or that is getting benefited with the help of the automations. And IoT is playing a very heavy role into this because of this is the nature of the man to be progressive. The man is a kind of means it is the mankind who is always progressive, and IoT is the latest thing the latest thing that is happening, and that is blended with the industrial automation is providing us lots of ease and access to the many of the services. So in this I'm just presenting a presentation for the industrial automation, thereafter how the IoT is leveraging, and what are the prospects that we will have into this domain of IoT and industrial automation together. So I'll be keeping this session very to the point. In next 45 or 1 hour, I will be connected with you, and I request all of you who are connected, who are viewing this thing in through the stream. So if you have the questions, so definitely you are welcome for asking me the questions, and I will try to give you the best of the answers which is available. Before I'll start, I'm just giving you for 2 minutes my introduction. So as sir has introduced you, I'm Amit Kumar Chaudhary, and I head the technology division of Pragyatmika. I have experiences with many of the organizations which is listed here in the government and the private domains, and I have specifically worked in this semiconductor domain for the last 15 of years. I have the experiences in the microcontrollers domain for all, from 8-bit to 32-bit of the systems. And my core domain has always been the embedded systems design and robotics and electronic systems design. So we are well into the design and developments of lots of projects we have been involved with. And apart from that, training is in my heart. So this is the one of the passion that I have. So side by side means along with the development job, we are also having a well-equipped training facility, and I head the training division also. So technology and training division both I head from Pragyatmika, and we have special recognitions with Microchip and MSME also for the development and for the training job. As far as Pragyatmika is concerned, we are into embedded systems, the IoT, embedded AI, thereafter your electric vehicles, the automotive of electronics. So all these domains we are working for the technology development, for the products development, and for the consultancy and trainings. So we have services for enterprises, institutions, all. And our primary job relates to consultancy, the training, and we have a well-equipped in-house R&D where we used to develop the lots of projects for the OEMs and ODMs. We have services for the industries, the startups, the universities and colleges. We have special services for setting up labs and trainings and all the facilities. Now, so this was a small introduction which we do. We are based out in NCR, and we are having the services for all over the globe. We are providing the consultancy and training services all over the globe. For today's webinar, I have kept the topics starting from the automation. So it is IoT and industrial automation, which we are going to discuss today. So specifically, I will be looking at first about the automation, what industrial automation is, how it has evolved, and then what are the architectures and how IoT is actually playing a role into this. So how the implementation of IoT happens, and based on this implementation of IoT, how this industrial automation is leveraging, what are the benefits that it can have. And then we will be looking at some of the key requirements, like if you are planning to implement an IoT and industrial automation, that I will be synonym with Industry 4.0 today. So how the IoT and what are the other factors are there, what are the other key actors are there, who would be the industrial automation, that we will be looking at. And thereafter, at the end, we will be looking at where are the scopes. Like if you have learned maybe that these are the things, this is how the technology is going to be implemented. But if you are looking for your scope, so that's what also needs to be discussed. And so at the end, I will be looking at the topics and the domains where there is an opportunity for a fresher and for the passed out, or maybe for the experienced candidates. And then at the end, we will be keeping the questions and answer sessions. So this is how we are progressing today. So starting from the first, so it is the industrial automation that we are going to talk. But before that, we are well known that how the industry has revolutionized. Well, from the 1784, where the steam engine and mechanization was there, it started with the vapor pressure, the steam power was there, the looms were there, to now we are into a world of a cyber physical system. So we have covered a lot of journey where the mass assembly production, then the automation, the computer-based systems, the PLC-based systems, we have seen all these things. And now we are in an age where it is not only the automation that is taking care of, but also the cyber physical systems, the self-decision making systems. And we are also talking about the production of the unique products for each and every individual without changing the assembly line of the factory. And that's where the main implementation of IoT and Industry 4.0 will come. So we are continuously progressing, and maybe sometime after, maybe some new technologies will come. But what it is today is this implementation of IoT, the architecture of this Industry 4.0 has increased the production very efficiently. Because there is a less of man intervention, there is a less of human intervention. So there is a less chance of errors are also there, and the production is increasing very high. This has resulted into the data manipulation, and it increases the software intelligence. And at the end, it not only provides the autonomy in the terms of the products, but also to the complete factory level. So self-decision making is the word which we will be using for the Industry 4.0 implemented factories, and same word which the smart factories, the American synonym for this is the smart factories. This is. So if I have to talk that what Industry 4.0 is, so there are the three key verticals that we will looking at. What Industry 4.0 has given from the Industry 3.0. And this is not only related to the product, but also to the services. So just I take an example that all of you are using the wattage just to view the timing. So that is maybe from any of the company, HMT, Titan, there are the lots of companies who were making the watches. So what happens that you use their watch, you purchase their watch from their retailers, and you use it for the viewing for the timing only. But this is just a product which has come from the factory to the dealer, then to the retailer, and then in your hand. Once you have purchased it, you don't have any direct relation with the factory. You don't have any direct relation with the Titan. So this is not an Industry 4.0 implemented product, or this has not been designed using an Industry 4.0 implementation. Now, if I take an example of an Apple Watch, Apple also making the watches, you purchase the watches through their dealer network. Now, once you purchase the watch, you come in the direct communication with the Apple Cloud. Now, tomorrow, if Apple wants to show some advertisements to you, and by viewing those advertisements, you can earn some revenue based on this. You can directly communicate with the Apple executive through your watch, that is through the cloud ecosystem. So based on the product, the product is the same. This is the watch is the product which is being used for the viewing purpose. But on top of that, there is a service is been on top of that layer, the service is being enabled, and using that services, you are always in communication with the Apple cloud. Through the Apple cloud, you are always in communication with the Apple management. So this is how the products have been integrated with the services. Always the communication has been made, and new verticals and the business models have come up. So this is a very small example of Industry 4.0 implemented products that is. Now in all the verticals that you can see this Industry 4.0 implementations, whether you take an automated factory, like you are purchasing cars. Right now, the cars are being manufactured on the assembly line, and it has been given to you. You have to purchase that. Now, if just think of a situation where you need a particular color of a car of a particular height, positioning, a particular driving style, and company is able to produce that car without changing its assembly line, and that product will be unique for you. That could be an Industry 4.0 implemented factory. And there, the real industrial automation with the help of the IoT would come. So it is. So there are the lots of examples that we can have from in the e-mobility sector, in the weaving sector, in the home automation sector. So there are n number of examples. So what the verticals it has affected is that in terms of the products. So there is always one more layer has been added on the products, and that make the revolutionizing into the monitoring and control of the systems. The manufacturing process is being augmented with the help of the 3D printings, the cobots, and the power solutions. Integrated HMIs and PLC systems are there. So it has augmented the manufacturing process. And the third and the most important thing is that with the help of this IoT implementations, the product itself become a source of a revenue generation again and again. So digital services is been tapped to generate the revenue again and again. So this is the first business benefit that we have. And then the predictive maintenances of the thing, we will be going to discuss what the predictive and preventive maintenances are in this session itself. So this predictive maintenance is going to save lots of money for the factory, because we will be able to predict that how much the system is going to last, and before that we can make the proper necessary arrangements for it. The better customer interaction is giving the better of the revenues, and production efficiency is also been increased. So these three verticals is getting affected by Industry 4.0 implementations, and this is how implemented. So this is implemented using the transition of automated factories to the self-decision making factories. And in this, there are the two things: the cyber physical systems, which is on the base of it. So cyber physical systems are playing a heavy role into the implementation of Industry 4.0, and then it comes through the cloud and edge computing. So the data analytics, thereafter the continuous monitoring, the continuous control, everything that is happening through the cloud layer. And the cloud layer is not getting bulkier by the help of the edge computing methods. And the services are the horizontal and vertical. Both of the services are getting integrated into the Industry 4.0 implementation, which means that we have a complete interconnection of the products and the service on top of it. So this service is being enabled through the means of the IoT. So that's why I call it the value chain through the IoT. And it is making the every product unique and customized. So just to take that example of your watch itself, that the watch is the same for each and every one, but with the help of the IoT service layer, you can configure your watch unique. Maybe the color, thereafter the alarm levels, thereafter the cloud-based alarms related to the weather, related to the newses. So you can customize your watch as per your requirements, the social network that you can connect for yourself. So these all things that you can do, and that's how the product becomes unique for yourself. So if I have to look at the implementation of the Industry 4.0 and how it is different from the generic industry process, so how IoT is making the difference into this Industry 4.0 industrial automation. So just for before, it is the we are looking at the generic industry process. So in the generic industry process, it starts in the lowest layer. It is the PLC systems. So PLCs are there for the low-level controls of the machines and for the statuses. On top of the PLC, we have the HMI interfaces through which we are controlling, and on top of that, there's a SCADA system. So through the SCADA system, everything is getting controlled. So here is the automation. This is not a self-decision making, but it is the automation that has been provided into all these three layers. So any of the assembly line production can happen with the help of these three. Now, how this SCADA system would be controlled and where the reports would be generated. So there is always a mesh system is there, and in this mesh system, the mesh system gets the orders and generates the reports manually with the help of the softwares or maybe manually also. And whatever the order comes to the mesh system, it gets fed into the SCADA system manually. And then if multiple offices are there or multiple departments are there, so for that management, the ERP system that comes, and the cloud layer is very rare in the case of a generic industry process. Only some of the industry processes include the cloud layer, and that's too only for their inter-network management, not for intra-network management, not for the inter. So this is the generic industry process is, and in this the communication is in a one way. So we are only having the down to top communication. If the top layer wants instant information that what is on the production line, how many number of products are getting produced, that information is very hard to get, because the cloud layer or the ERP layer, like the management, if wants to know about the production efficiency, so it has to communicate to the production department, and then through the mesh layer, the production ratio will be calculated and it will be sent to the management. So there is always a lag. Maybe it is a day or a week or even maybe of a month. But so this creates an issue in the real-time implementations of the system, because that we are not using any of the automation into the system. We are not using any kind of IoT layer into this. And this is giving a very bad effect on the overall efficiency of the organization. Whereas if we talk about the Industry 4.0 implemented processes, so we are having the connectors over here. We are also having the 4 layer, but all these 4 layers are actually the implementation layer levels, and the top layer always remains connected with the lowest level because of the interoperability nature that is being provided. So we have the at the lowest layer, we have the gateways and software agents through which the things like the things are the software model of your hardware, like your machines are there. Now those machines are the hardware things, but to know the efficiency, to give the commands, to know the efficiency of those machines, we have to make a software model of this. So things are the software modeling for them. We have the lots of old machines also, so legacy items that, and so through these libraries, the agents, it passes through the protocol. So for the communication layer, we have the protocols. Through this protocol, the cloud layer is communicated. So data is getting stored on the cloud, and through this cloud layer, the top layers, the business systems, the operational systems, and customer interaction systems, SCADA systems, everyone is connected. So if anyone wants the report, they can get in the real time, because on the cloud, every time the data is getting stored. So the data is gathered at the connect layer, but always it is getting stored onto the cloud layer, and that's why from here the communication can happen between all of them, and it becomes a two-way communication. So in a real time we can get each and everything. So this is the one of the best benefit that we can have. If I have to give an example, a very small example, if I have to give, so many of you are using the courier services. Normal courier delivery services are what that from hop to hop the courier destination packets are updated, and you can track that now my courier packet is at location number X, and it will take me 2 days to reach to me. And once it gets at the delivery final destination, again you get the information that the courier is at the final destination, and then it is in the delivery process. The courier guy comes to you, it gets delivered. Again, he updates the system. So this is a one-way communication that is happening. If in the real time, the like any XYZ courier company is, if in real time, if he wants that how many couriers are on the delivery line, how many couriers are getting delivered in an hour, or how many couriers are getting delivered in a particular minute, he will not be able to calculate it, because it is a manual update of the systems are happening. The courier packet gets delivered to you, and then once he goes back to his office, then it's get updated. So real-time information is not possible. But think of an Blue Dart services, or maybe the Amazon services. So as the packet is in the transportation, also you get the information. And secondly, once the courier guy is at your doorstep, you get the message and the call that the courier guy is at the doorstep. As soon as he delivers you, it is getting updated in the system that the courier packet has been delivered at this particular time period. Like courier packet has been delivered at 13:51 minutes. So in real time, if the Amazon top layer management wants to know that how many courier packets are getting delivered in an hour, what is my delivery rate, he can calculate in real time. So this is what the delivery mechanism is the same, but on top of that the service layer has been added, that is with the help of the IoT, and everything is in a connected environment. So this is how the production layers, this is how the services layers, this is how the everything could be automated. And this industry is not only the manufacturing industry, not only the service industry, but it is the complete integration that I'm talking about. So I hope that this is a clear thing, that how we are integrated from the top layer to the bottom layer, and a two-way communication is happening in the help of the Industry 4.0 implementations. So if I have to look at that, what is the backbone of the Industry 4.0 implementations with these IoT systems are? So actually it is the cyber physical systems. So this cyber physical system gives you the control to transform and give the interaction of the physical world through the means of the information. So you have lots of electronics products, the consumer electronics products in your home, like you have a air conditioning device in your home, but you want to control it. So there is a very small thing that you can attach a remote controller into it, and you can control it through any of your mobile phone, or maybe through the website, anything. But now you want to gather the information from your air conditioning device, like how many hours it is running, thereafter what is the temperature levels it is turning on the compressor, what is that temperature levels it is turning off the compressors, what is the filtration ratio, what is the humidity that it can control. So to know all these things, and you want to also know that how much the voltage that it is consuming, how much the current it is consuming. So to know all these things, you have to make a model of it. So with the help of something, with the help of some sensors, you will make a model of this physical item, this air conditioning device, and then you will implement some system. That system will have some communication interface also, and then completely you can make a complete software model of this and can get the information from your air conditioning device. This is the same thing that is happening in the terms of the manufacturing industries, the robots and the manufacturing machines also. So this system complete is called the cyber physical systems, which has the three verticals: the control part, So through the control part, you can control your devices remotely with the help of your algorithms. It has the communication part. So whatever the data that has been gathered, that needs to be communicated to the cloud layer. So it is the communication part and the computation part. So whatever the data that it is gathering, so every raw data is not being transmitted to the cloud layer. There is a need of a computation. That computation happens, and then it is been transferred to the cloud layer. So these three verticals, the control, the communication, and computation happens for this modeling. Means whenever we are going to implement this Industry 4.0, the modelings, and behind this, there are the embedded devices. The microcontroller-based embedded devices are there with the help of network monitors, the IoT sensor, the IoT communication layers. So the radio chips that we call, the wireless devices that we call, with the help of the embedded devices. And we have some demonstrations that I can show you. And then we have the sensor networks. So those sensor networks are just not gathering the information, but they have to be plug and play nature, like any of the pen drive that you purchase and just insert into your PC and it starts working. Same way, the system should be in such a manner designed that any of the sensors or any of the different vendor sensors that we purchase and that we connect with our network, that should start working straight away. So that's what it is. Not a hard coded things that we design. It is an interoperable thing that we design into this IoT network of the Industry 4.0 implementations. So plug and play nature. And then we have the intelligent mechanisms and our algorithms and for the system engineering and all. So this cyber physical systems is completely designed around the microcontrollers with the help of the wireless radios. It has the sensors and it has the intelligent algorithms to do the things. So this cyber physical system is playing this role. And what the other things that we require in case of setting up this Industry 4.0? So this is the IoT. That's the first thing is. And if we are implementing it into the industrial manners, so this is called the industrial Internet of Things. So there is a very small of a difference. The protocols are almost same, but there is a very small implementation differences are there in case of IoT and in case of industrial IoT. Then we require the cyber physical systems. Then based using these two, so your smart factory or Industry 4.0 implemented factory is designed with the help of the machines. And whatever the data that we gather, that gets into the big that is getting captured into the big data environment. So the analytics is provided through the big data on the cloud. And what the benefit that we can achieve through the IoT. So not only the production line control or not only the monitoring of the production line, but the best thing that we get and what is the most talked about Industry 4.0 is the predictive maintenances that you get. So what predictive maintenance is that I'm going to discuss, but it has a very huge business impact if we are implementing the complete of the predictive maintenance for your machines. Your like in a normal way, if the machine is going to last for maybe for 2 years or 3 years in a huge production environment, with the help of the predictive maintenances, you can increase the lifetime and simultaneously you can save a lots of cost onto this. And in this Industry 4.0, the interoperability is the very necessary thing. It is not a hard-coded designs that we make. We have to make it into a plug-and-play environment. And then sensors are also playing a very important role. So these are the actors for any of the setup of this Industry 4.0. So what the automation that we get is that it is again the assembly line process, but in the assembly line process, what happens that either the machines are working or the human are working. But now we are in the age of the Industry 4.0, where we are talking about the cobots. Collaborative robotic is there. So in this, the machines and the man both are working together. Both of them are sensing, with the help of the sensors and with the help of the processes, both of them are knowing the presence of each other and they can work collaboratively. So this is the required
Amit,
things whenever we are planning to. Yes.
Amit,
Yeah, please.
Can you change the slides, because the
Can I?
front slide only it was. Yeah, change the slides.
Yeah.
PPT slides.
It is not changing. I'm.
Yeah, it is not changing, sir.
Okay, just a moment.
Yeah, now it is okay.
It has not changed from the beginning.
Yeah, from beginning it was not, and that was I was trying to, but
Sorry,
it's not happened. Okay, now it is okay. So you are presenting something. Yeah, now it is changed, sir.
Okay, now it is proper. Now it is proper, I hope.
Yeah, it is proper.
Okay. Okay, so if it is
yeah,
not,
it is
so
proper, sir.
Okay, so I just for 2 minutes, I just whatever I have talked, I just 2 minutes clips I give. So I had talked about the industrial revolution, the history from where we have started, the industry 1.0 to industry 4.0. Then I had talked about the industry 4.0. Hope the slide is visible, Sharma sir. The industry 4.0 slide, in which we are talking about the business models,
Yeah, it is
the manufacturing.
visible.
Okay. So this is what we have talked about, the three of the models, the verticals, and I had talked about the product is unique and customized. Then I had shown you the implementations for. So in this, the layer starts. There are the two things: the generic industry process, and then I have talked about the industry 4.0 implemented process. So in generic industry process, it is a one-way communication that is happening from the top layer to the bottom layer, and from the bottom layer to the top layer. And if the top layer wants to gather the real-time information, he is not being able to. And if it is an industry 4.0 implemented, so we have the connectors at these layers, the connect, the communicate, and the automation is provided at the cloud layer. And then we have the integration done at the top layer in the cloud data itself for all the actors, for all the business information seekers, and the two-way communication is possible. So that's what I had discussed you. And then I was talking about the cyber physical systems. So in this cyber physical systems, we have the three verticals: the control, the communication, and the computation. And into this, the main thing which is making this cyber physical system possible is the microcontroller based embedded system devices with the help of the wireless radios. And then we have the sensors, which is in a plug and play environment, the interoperable. And we have the intelligent mechanisms or system engineering practices. Thereafter, we have the industry 4.0 implemented things, which I was discussing. So into this, we have the requirements for the IoT, for the cyber physical systems, for the smart factories, and the big data is there where the data is getting stored and analysis has been done. Thereafter, we have the predictive and preventive maintenances, that is the leveraging of IoT, and the sensors are the required thing whenever we are going to set up the industry 4.0 environment. So this is what I had discussed till now. Now I was giving you a yes. So I was talking about that there is a small of a difference into the IoT and industrial IoT. So what this difference is that both of them have the things. In case of an IoT, we are mainly talking about the consumer-centric home automation, home appliances, control applications, and the non-critical items. Whereas in case of industrial IoT, whenever we talk, it is the industrial setting IoT that we talk about, which is mainly related to the instrumentations and the sensors involved into the machines, and here it is not the control, but majority of the monitoring purposes comes, and this is the very of the time and performance critical, and it has to be very much reliable and secure. So this is the application differences of the IoTs are there in case of a consumer centric and industry centric, and so that's why the two different things are being talked, IoT and industrial IoT. And industry 4.0 is the movement I call, which is not only focused on the manufacturing, but it is applicable to all of the things. And here the physical technologies of the factories are integrated with IoT, and this is a movement that has been created in which we are in now. So this was the small difference between the IoT and industrial IoT, which I was talking about. Now, whenever I have to implement this industry 4.0 into this using this IoT, so what are the considerations and what are the things that we consider about? So it all starts with the industrial thing. So your PLCs, HMI, robots, sensors, everything is there, and these are the physical objects which is there on the assembly line on your shop floor, which is being used for the control and the production things. But to automate them, we need to make the models of it, and for that we are these industrial things. So with the help of these cyber physical systems, you are making the industrial things of these physical objects into the factory. And then we have this connectivity. So this connectivity, on the connectivity layer, we have the gateways, the routers are there, and through this the industrial things are gathering the data from your physical objects. This gets through the gateway. Some of the computing is being done at this layer, and then it goes to the cloud platform where the data is getting stored. And then you have the dashboard systems, the alarms, analytics, all these are the software systems through which the integration of the cloud platform is there, and you are gathering the data in the real time from these physical objects. So whenever we are going to design any of this Industry 4.0 implementations, the first and foremost requirement that it is the sensor-based systems. So low power is the one requirement, because many of the times we are battery backed up systems that we design. And the sensor selections that we have to look at, there are the sensors like any of the sensors that you take. So for your consumer application, the sensor could be different, whereas in case of the industrial application of the same thing, we require a high reliability of the system. So this is what that we will require. And then we will have the communication medium. So in this communication medium, we are having this wired or wireless communication protocols, whatever we think of, and then the cloud platform. So the cloud platform selection is also much required, because based on your data, how much of the data that it comes to you, how much of the computation that you have to do, what is the network bandwidth that you require. So all these things are being selected based on all these things, the cloud platform is being selected. So these considerations that you have to make. Thereafter, the legacy systems. So maybe there are the two kinds of systems you will have in your factory. One is that which is already existing systems are there. Those will be the legacy systems. Those are the older systems which is not very much compliant with your IoT network. And then it will come the newer systems who are directly plug and play environment and working in your system directly. So you have to also make a mechanism through which you can make the legacy systems incorporated into your IoT network. And the very much important thing whenever you are implementing the Industry 4.0 into your network is the IoT security that we talk. And IoT security is why it is required. It is not just only for saving of your data, but the hardware level of security is also that we require, and the lots of compliances that you need to follow when the product is in the market. So So to keep the product safe also, you have to include the IoT security layer from the time when you are getting when your product is getting manufactured, when it is getting planned, when it is getting manufactured. At that same layer, the IoT security starts. So that's why from the very beginning of the thing, the IoT security layer has to be there in your complete of the manufacturing process. And then we see the integration and the validations. So these are the considerations I was talking about. And then now if I have to select that, then now if I have to talk that what are the two of the important things in the Industry 4.0 implementation is, so the sensors that I was talking about. So sensors also plays, because in the cyber physical systems, one side we have the microcontroller based embedded systems, and then it is the sensors who are gathering the data, the real-time data it gathers. So for each and every sector, like whether it is the temperature, you have to consider whether it is the power, proximity, material, position. So for each and every kind of physical, for each and every kind of a physical thing, you are having some sensors, and with the help of these sensors, you are implementing the software model of it. Now there is a small difference is there in the sensor selection, which I'm just showing you. So this is a one example where I'm showing. So normally, like we are having the proximity sensors. Generally for the proximity, we are using either the IR sensors or maybe the ultrasonic sensors, which has a single point of a measurement. So single pixel measurement it has in a single direction, or maybe just in case of ultrasonic, it has a spectrum. In that spectrum, the sensor is throwing its waves, and if it is getting reflected back, you know that the object is there in front of you. But what will happen that if you have to, in the industrial environment, just only the one position proximity is not enough. So you have to look at for the some kind of a movement also to consider. You also have to consider about the height, width, depth of the items. So for that, we will have the array of pixels to measure. So for this purpose, we are having the TOF sensor, the 3D time of flight sensors are there. So this is also giving you the positions, but the implementation level is different. This has also been implemented using the IR, but the implementation is different. In case of a normal IR sensor, you are having just a single line of a measurement, whereas in case of a 3D time of a flight data, the same IR is there, but now you can see that we are having a 3D data into this, where the same IR is there, but in the left that you can see that it is the complete measurement of the height, width, depth, everything is getting measured into this, and then the IR spectrum on the top that you can see. So with this, you can always be implementing the implementation. The technology is almost similar, but the implementation differences are there of the sensors, and this is how the industrial how this is leveraging the Industry 4.0 implementations with the help of its implementations. So this sensor is one thing that we have to select very wisely for our requirements. And then the second thing that it comes the computing layer. So we are gathering the data and we will be pushing that data to the cloud. But before pushing that data to the cloud, on the edge layer, there is a requirement of computation. So we are now using the distributed computing environment where we are processing the data and performing the main of the computations job as per their nodes. Like we are implementing an Industry 4.0 implementation for your factory, and in that factory there are the different of the departments are there, and the different production floors are there. So each of the production floor will have the machines, and on those machines will be grouped together, and then on the edge layer the computations will happen. The boards will be used. Those boards will be keeping the data from these machines, and before sending it to the cloud, it will process it, and then the final data is sent to the cloud for the analytics and for the information purposes. So edge layer is implemented into this distributed computing environment where processing and the computations are performed on the classified device nodes. And these devices are either the simple edge computing devices, or if it is a small implementation, so gateways are also could be used as the edge computers. So the same device could be working as the gateway and the edge computers together. And there is one more thing that comes into the computing is the introduction of the fog layer. So if we are working in a very large network of an infrastructure, then only the edge layer and cloud layer doesn't satisfy. So between the edge layer and the cloud layer, we have a fog layer. Into this, this is the network management thing happens. So on the edge layer, we are gathering the data, we are doing the analytics, we are doing the real-time processing of the data, and the real-time processed data goes to the network level, that is a local network level computing device that acts at the fog layer. And here again the standardizations of the data happens as per the cloud protocol, and then it is being sent to the cloud layer. So depending on the complexity of the implementations, either we can use only the edge and cloud layer, or we can have the fog layer in between. So if it is a kind of a portable devices, so we can have only the edge and the cloud layer. But if we are working in a smart factory environment, so we can have the fog layer into this also. So these two things are very much important while we are implementing the Industry 4.0 implementations, the sensors and the computing capacities. And based on this, the CPS is designed. Now, what the benefit that we get using this Industry 4.0 is this predictive and preventive maintenances. So normally what happens that in case of a normal factory environment, we are having the machines, and we have a scheduled maintenance period. Into this scheduled maintenance period, if the machine is gone bad before of it, then we call the persons. But generally, we are waiting for the machines to get failed. Like just again, I will be taking the example of that air conditioning device in your home. So you have air conditioning device in your home, and you have a scheduled maintenance of a 6-month period. And after each of the 6 months, you are maintaining your air conditioning device. But maybe this time the summer was really very high and AC was consumed over its capacity. So maybe what the condition that comes after 6 months, that has come after 2 months only. But you have a scheduled maintenance of it, so you will maintain it after 6 months only. But what has happened that in these 4 months, the air conditioning device has worked at its lower of its efficiency. It might consume the more of the current, it might produce more of the vibration, anything can do. So that's why we require a kind of a monitoring where we are continuously monitoring the each and every process of it, because we have the CPS system enabled onto our air conditioning device. And with the help of this continuous monitoring, I can predict in real time that what is the condition of my air conditioning devices, when it is going to be bad, when it is what kind of service that it requires. So this is how it is possible. This is only been possible if you have implemented the CPS, the software modeling you have done into your air conditioning device, and then through the means of the IoT, you are always being connected with your air conditioning device. So this is the same that we can implement into our factories also, and this is how it is implemented. And we are getting all the informations in real time, and the maintenances are being called. So again, there is a layering of the maintenances is being done, that what is the less expensive equipment, what is the mid expensive equipment, and what is the most critical equipment that requires to be maintained, and this is implemented. So this thing is called, technically this term is called the CBM. This is condition-based monitoring. And this condition-based monitoring is not only the sensor-based solutions, or it is not only related to the vibration. So for each and everything that it requires, so any of the CBM solution has the sensors for it. It has the software embedded software devices, it has the algorithms, and it has the mechanical designs for the control purpose. So this four together makes a complete of a CBM solution. And for this, we have the lots of diagnostics and the sensor level plannings are there. And just for the explanatory things, so normally whenever you purchase any of the product, so you have the warranty coverage of it. After that warranty coverage, you have a scheduled maintenance of it. Once this scheduled maintenance finishes, so then it comes at a potential failure. So any of the time something can fail, maybe after 3 years or 4 years, anything can fail. And then based on the particular conditions, you implement the maintenances of it. Like if the compressor is failed, so you maintain the compressor. If the duct is failed, so you maintain the duct. So and then finally it gets failed. So these are the stages of it. And on the lower of the side, we have the stages, like once the defect is initiated, so then it goes onto the curve of the potential failure of the system, and the multiple of the conditions might occur, like current draw will increase, the temperature will increase, it might have the excessive of the loads. And as this curve is going down, as the life expectancy of your machine is going down, the cost and risk of the system is getting increased. So to overcome this situation, we have this CBM, and in this we have the algorithms implemented, and through this algorithms we can predict in advance. Just for a small example, you are having the time and frequency from any of the motor. So this is for a motor that I have taken an introduction. We have the time, and this is the frequency for your harmonic frequency from your motor. So we know that whenever it gets powered up, there will be the some frequency change that might happen. That will be the some increased frequencies that it will have in the amplitude. And then there may be spikes. So what this spikes is, and what this spikes will make the sense. So this, if we are measuring the frequency against of the time, so this is in the third graph that you can see. So we have a normal range of frequency spikes that should happen. But if the system is going bad, so on and over of a time period, we will have the few spikes which is beyond our permissible limit capacities. And if we are getting these spikes beyond our limits, so we can set in our algorithms that the warnings and alarms needs to be generated. So this is how we can calculate the things related to our analytics, and these are the physical things like frequency and time. Time is the constant that it will remain. The frequency will be gathered, and if we are calculating both of the things related to our physical object motor, so we can make an algorithm through which we can generate the warnings, alarms, and everything for the maintenance person. So this is how the CBM is acting over here based on these two parameters, and giving us the proper predictive maintenance features. So till now I have talked about the implementations, the actors who are required for the implementation of the IoT into your industrial automation network, how the industrial automation is done, and then what is some of the benefits that we can make available with the help of this IoT. So if this is how the industry is evolving, there is lots and lots of products are getting to be connected, and very soon, in just next 4 years, it is expected to be more than 50 of the billions of items who will be connected. So beyond it would be more than the complete of the number of people on the earth. So this is how the graph is increasing, and we are in an edge where it is increasing at a very high of the curve. So, and the domain of the increment is also increasing. Like initially it was just the connectivity was there, then it came the era of the personal mobiles. Now then it came the digitally social society sets in a sustainable world, is like where we have the connected apps, the connected social networks and everything. And now we are in the age where we have the connected, we are in the age of the connected devices. So our all around our devices are going to be connected. And what will happen that if these devices have got challenged with security, so that will make our lifestyle at a very of a risk. Like you are using any of the device who is alarming you to let you know that this is the time to take your medicines, or maybe you are using the baby monitors, maybe you are using the IoT controlled glucose monitors, and if someone has barged into your system, he has made some changes into it, so that will be a life threatening for you. So that's why as the IoT is increasing, there is a lots and lots of challenges that it is increasing in the terms of the security. And there is a very pretty thing is that these are the so small devices that we cannot implement the standard security protocols into this, because we don't have the standard processing capacities, and for encryptions and all we require the high of the capacities and the computing. So that's why in case of implementation of the IoT security, also there is special mechanisms are required, and that has been implemented, where we have to layer level of a security, and we are having the protocol layer of a securities. So just for information, we have the masterclass series is going on, in which we are having the IoT security master classes. So anyone can have that can take benefit of those master classes, that what is the benefit of this IoT security is, and how we can implement the IoT security into this. So this IoT security is actually playing on all the four layers, whether it is the information security layer, whether your IT security layer, the physical security layer, and the operational security layer. So these all are the four of the domains of IoT security, four of the domains of the security. And if we are talking in the terms of the IoT, all of these domains needs to be merged. So on the physical layer, we are having the hardware layer of IoT security. With the help of the chipsets, we are making the security. On the operational layer, we are having the protocol security. On the IT security layer, we are having the rules implementations for the communications. And on the top layer, we are having the software security mechanisms through which we are making possible for not the breach of the information to the irrelevant people. So these all are coming under now the IoT security, and this is been not only for the user security, because the data is become now an asset. So for the digital assets, this security is there, and we are
Amit sir, let us conclude now, because we have a time bomb.
Objective, yes. Yeah, please. Yeah,
hello,
it's just clock in 2 minutes. Yeah. I'm completing in 2 minutes. Just this opportunities. So we are having this and into this business domain. So
fine, sir, fine.
So, and we are having in all of these, whether it is your home automation, the wearable, the electric mobility, the aerospace. Okay. So I'm ending it. Thank you for that, because the time is limited, so we can have some other day. It's not an issue. Any questions you have? Any of questions that you have?
Anything, sir? Once I get, I'll just send you the questions on WhatsApp or through mail, so that you can communicate with the students.
Okay. 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 Okay, please send it.
Okay, 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 sir. So thank you very much for your wonderful knowledge
So
sharing in
thank you
this
everyone for being connected. And I
entire
leave, sir. Is it over?
session. I
Thank
hope
you.
my
Thank you.
participants they
Thank
have
you.
learned
Thank you for the
many
positivity.
things and they will come up with certain questions,
Yeah.
and I'll give the questions to you
Okay. 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 Thank you. Please.
so that we can interact and we can furthermore
Sure. 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 Not an issue.
do such type of events more and
Sure. Sure. It was nice.